Hello, everyone, and welcome today to my COMP Lightning Talk. My name is Milton Camacho, and I'm a master's student at the University of Calgary. First, a little bit of background information. Parkinson's disease is a severe neurodegenerative disorder that affects a lot of people all over the world. Parkinson's disease has evolved from being recognized as a purely motor disease to a complex heterogeneous neurodegenerative disorder. Even though its diagnosis has been the main priority for a lot of researchers, it still remains a challenge, even for movement disorder experts. In this context, machine learning can help us identify biomarkers for the early diagnosis of Parkinson's disease, and especially for those with mild cognitive impairment. The goal of this project is to develop and evaluate interpretable machine learning models that can help us predict cognitive decline in patients using a wide variety of deep phenotype biomarkers collected from multiple datasets. We propose three aims. First, to collect and fuse databases from local, national, and international movement disorder clinics, as well as the Canadian Consortium on Neurodegeneration in Aging and the Parkinson's Progression Markers Initiative, to establish the biggest database of Parkinson's patients with information on cognitive decline. Second, the use of deep learning models to impute missing data. And third, develop sophisticated, interpretable, deep convolutional neural networks models using this new database. From these three aims, aim number 1 has already been accomplished, and number 2 and 3 are underway. Along the course of my time working as a COMP awardee, I have been working in multiple projects. For example, we developed a classical machine learning model using a random forest classifier accompanied by a relief feature selector to classify between Parkinson's disease with mild cognitive impairment, and Parkinson's disease with dementia, achieving an accuracy of 80%. These are promising results. However, they're still work in progress. Furthermore, I have been working on the development and application of interpretable machine learning models to our collected data. For example, generative inferential models, like the one proposed by Matthias and colleagues from the MIP lab at the University of Calgary, where the idea is to learn the high-dimensional space representation of the brain morphology variability condition on a certain variable, per se, clinical diagnosis. In this example, they used age. The way they did it is they encoded or they extracted the information from this three-dimensional volumes into their vectorized space, where they froze all the information encoded from the brain and they modified the age of the patient, whereby modifying the age, the model would be able to recreate different brain structures that would correspond to the modified age. If we now replace the age term with our diagnosis, all of a sudden we have an interpretable deep learning model that can not only help us predict the disease, but can also produce an explanation of why a certain patient could be classified, or what would the same patient with the opposite diagnosis look like. We're also working on attention convolutional neural networks, where the main idea is to take a three-dimensional brain scan, extract features from it using a convolutional neural network, and add an attention network that will essentially check if the information at the middle of the network matches the information at the end of the network after all the features were extracted, and give more importance to those features that were present at the middle of the network and are still present at the end of the network, because the model is more likely to use those logics to produce a prediction for the patient to either be Parkinson's or healthy patient per se. This is still work in progress, and we hope to produce some great results soon. My project contributions are mainly that we're going to produce a well-documented approach that could be used as a baseline, which is a terrible gap in the literature when it comes to the classification of Parkinson's disease. For this, Our algorithms will be made publicly available so that the research community can use them and compare against or build upon it. Thank you all for your attention.